Okay, this is Unit 6 test review. This is part 1 video. There'll be 2 videos. As a reminder, you need to show all your work in order to receive full credit for the problems. This says identify the key features of the exponential function f of x equals -3, 5 to the x power, and its graph. So there's a couple different ways you can do this. We could first just graph it, and then I would put, I don't have to put f of x, I can just put -3 times 5 to the x power, and it will give you all your features that you need. So I always start my y-intercept is -3. I'm going to have 0, -3. My asymptote is the line in which the graph approaches but never reaches, so that would be y equals 0. As you can see, as x gets bigger, the graph decreases. So the graph decreases as x increases. The domain, it's going to hit every x value. So your domain is all real numbers. And the range would be y, and the y's are less than 0. So y is less than 0. Also, you can look at your key features. So remember you have f of x equals a b to the x. A is your initial or your y-intercept. The negative shows that it decreases as x increases. There's nothing behind it, so that tells you that is your y equals 0 for your asymptote. For the graph of f of x equals 4x, I am going to plug, we're going to do -1, 0, 2, oh, I forgot 1. 1, 2, 3. So 4 to the -1 power is 1/4. 4 to the 0 power is 1. Anything to the 0 power is 1. 4 to the first power is 4. 4 to the second power is 16. And then 4 to the third power is 64. So I'm going to graph this, -1, 1/4. 0, 1, 1, 4, 2, 16, and then 3, 64 is going to be way off the graph. So it's close to that. So from here you can see that the asymptote is y equals 0. Your domain is going to be all real numbers. Your range is y is greater than 0. Your y-intercept is 0, 1, and the graph increases as x decreases. Write the exponential function that represents the table of values using y equals a times b to the x power. A is your initial or your y-intercept. B is your ratio. So that's the first thing we need to do is identify these things. So I can, for this one, I have 0, 4, 1, 2, 2, 36. I can say my A or my y-intercept is 4. Then I need to find my ratio, and I can do that by putting this in the calculator. So I'm going to take 12 divided by 4. That's 3. So if I take 3 times 12, I should get 36. And then I take 36 times 3, I should get 108. Yep, so my ratio is 3. So my function would be y equals 4 times 3 to the x power. Now let's look at this one on B. My initial or my y-intercept is going to be 18. My ratio, I take 6 divided by 18, 1/3. Times that by 6, I get 2. So I know 1/3 or 0.33 repeating is going to be my ratio. If I I'm dividing by 3 each time, I can literally just put a 1, make it a fraction, put a 1 above it. So then I have y equals 18 times 1/3 to the x power. All right, number 4, does this represent an exponential function? If yes, name the common ratio. Josie has saved $20. She triples the amount she saves each week. Yes, R would equal 3. The number of bunnies at the zoo tripled from 1 year to the next. Yes, R also equals 3. Number 5 is exponential growth and decay. So the population of a town is 21,000 and it grows at a rate of 5% per year. Write and solve an equation to answer the question. What will the population be in 6 years? So your exponential growth is f of x equals a times 1 plus r to the n minus 1 power. R has to be rate in decimal. Okay, so here we have f of x equals 21,000 times 1 plus, if I don't know how to make my percent into a decimal, I just take 5%. I take 5 divided by 100, which is 0.05 to the n. And I'm sorry, it is not the n minus 1. It is just to the nth power. So n is the number of years, so it'd be 6. So 21,000 times 1.05 to the 6th power. We put that in our calculator. We are going to get 21,000 times 1.05 to the 6th power. You're going to get 28,142. Now, number 6, there are 6,400 bacteria in a lab dish. The bacteria decreases 7% each day. Write the exponential function that models the situation. So it's decay, it decreases its decay. So instead of 1 plus r, you'll have a times 1 minus r to the x power, the n power. So then I have 6,400 times 1 minus 0.07 to the x power, which if I reduce that, or it would be 6,400 times 0.93 to the x power, and of course that's f of x equals. So how much bacteria will there be after 5 days? Well, I put 5 in for x, so 6,400 times 0.93 to the 5th power. So again, I'm going to go to my handy dandy calculator. 6,400 times 0.93 to the 5th power. And I get 4,452.4. 4,452.4. How much bacteria will there be after 21 days? So I'm going to do the same thing. I have 6,400 times 0.93 to the 21st power. 6,400 times 0.93 to the 21st power is 1,394.2. 1,394.2. And that is part 1.